Welcome to Technogate. I'm myself Jagan. I'm the physics faculty in Technogate. In last video, we discussed about spectrum, not a spectrum, Bohr atomic model. Bohr atomic model, radius, velocity, potential energy, kinetic energy, and total energy. And there are so many formulas we have discussed. In this video, we are going to discuss about the hydrogen spectrum. And merits and demerits of the Bohr atomic model. So what is hydrogen spectrum? Already we discussed one formula we have derived in last video, that is energy formula. Energy of electron, or whenever this electron jumps from higher orbit to lower orbit, how much energy is released, or whenever electron jumps from lower orbit to higher orbit, how much energy is absorbed. So this is the formula. Hydrogen spectrum. Hydrogen spectrum. Hydrogen spectrum. So we have discussed already. This is the ground state. N is equal to 1. It has energy is minus 13.6 electron volts. First excited or second orbit, that is equal to E is minus 3.4 electron volts. Next to N is equal to 3 minus N is equal to 3, which has energy of minus 1.5 electron volts. Next to N is equal to 4 minus 0.85 electron volts. Right? Now, whenever electron jumps from first excited state to ground state, this is even, energy is even, it's a E2, it's E3. How much energy is released? E2 minus, E1 minus E2, E1 minus E2. Whenever it jumps from excited state to first excited state to ground state, we can call it as a first excited state or second orbit. Right? How much the energy is, the difference between the minus 13.6 to minus 3.4, that is equal to 10.5 electron volts is released. This much of energy is released. This energy has some particular wavelength. Whatever the energy is released, it is in the form of the electromagnetic radiation. It has some particular wavelength. What is the wavelength of the energy, which is when electron jumps from the n is equal to 2, n is equal to 2 నుంచి n is equal to 1 వచ్చినప్పుడు ఎనర్జీ వస్తుంది. ఎనర్జీ అనేది ఎలక్ట్రోమాగ్నెటిక్ స్పెక్ట్రమ్, ఎలక్ట్రోమాగ్నెటిక్ వేవ్ వస్తుంది. ఎలక్ట్రోమాగ్నెటిక్ వేవ్ యొక్క వేవ్ లెంత్ ఎంతో మనం ఫైండ్ అవుట్ చేయాలి. సో దానికోసం మనం ఫార్ములాస్ కూడా చూసాం. మనం ఫార్ములాస్ ఏంటంటే E2 minus E1 is equal to minus 13.6 into Z square R C into 1 by N. Here it's a E1 minus E2, not E2 minus E1, E1 minus E2. N2 square minus 1 by N1 square. And also wave number V is equal to 1 by lambda is equal to, right, minus 13.6 or R into Z square R into 1 by N2 square minus 1 by N1 square. What is R? R is Rydberg constant. We can call it the Rydberg constant. R is Rydberg constant. This R value is R is equal to Rydberg constant value is 1.0 something 79 into 10 power 11 meter power minus 2. This is the Rydberg constant value. After simplifying, we get wave number. Wave number is equal to 1 by lambda square z square r into 1 by n2 square minus 1 by n1 square. Right? Now, so this is the ground state, n is equal to 1 minus 13.6. N is equal to 2. N is equal to 3. N is equal to 4. N is equal to 5. So like this. Here it is a continuous spectrum. We can call it, there is no gap. Because here E is equal to 0. E is equal to 0. Whenever electron jumps from the higher orbit to the ground state. So like this. Higher orbit means this is the first line. And here it emits some particular energy. Now n is equal to 3 to 1. It also emits the energy because minus 13.6 here it is a approximately 1.5. So whenever it is released from jumps from n is equal to 3 to n is equal to 1 minus 1.5 plus 13.6. This much of energy is released. Right. Now here to here. Now here to here. If you observe this spectrum, this is called spectrum, hydrogen spectrum. If you observe this one, electron jumps from higher orbit to the lower orbit and it emits the energy. That energy is in the form of that energy is in the region of the ultraviolet region. What is an ultraviolet region? Ultraviolet region. This series is called Balmer series. Lyman series. We can call it a Lyman series. Lyman series. Lyman series in the sense whenever electron jumps from the higher orbit to the ground state, then that series is called Lyman series. Then the energy which is released here is in the region of the ultraviolet region. Next, if electron jumps from the higher orbit to the first excited state, or n is equal to 2, second orbit. So like this. This is called Balmer series. This is called Balmer series. Whatever the wavelength is released or emitted in this region is in the visible region. So we'll discuss how much wavelength, what is the wavelength of Balmer series to discuss. Right. Like this, Lyman, here it's a Balmer, next one is a Fashion, next one is a Bracket, next is the fifth one. So for Balmer, lower energy state level is 3. Next is Fashion, lower energy state level is 3. And it's equal to, here it's a 3. Right? For Fashion. For Bracket, lower energy level is 4. For Fifth, n is equal to 5. Then we discuss all these things: Lyman, Balmer, Fashion, Bracket, Fund. How much energy is released? What is the wavelength? In which what is the longest wavelength and what is the shortest wavelength? Right now. So this is the table. We had it. Right. Now, first one is Balmer series or Lyman. First we will discuss this one, then we will go later. Here, if you observe here, this is the Lyman series, Balmer, Fashion, Bracket, Fiffin. All these are whenever an electron jumps from the higher energy level to the lower energy level, it radiates some particular energy in the particular wavelength. Depends on the wavelength, we divide like this. First one is Lyman series. In this Lyman series, this is the ground state. So to the ground state, all electrons are jumps from the we'll continue later. There is technical problem. We'll continue.